Astronaut Neil Armstrong, the first man on the moon, embarks on a perilous mission, not to space, but deep into the Wegas forest, a tropical rainforest in Ecuador. He's not alone. Over 100 individuals accompany him: soldiers, scientists from diverse fields, and even a film crew. Their objective: to locate a mysterious subterranean network known as the Teos Caves. Legend whispers that these caves are an entrance to a vast underground system. Hidden within its depths, a library made entirely of metal, even the books, inscribed with cryptic symbols no one can decipher. Many believe this library belongs to an unknown extraterrestrial civilization, holding knowledge that could fundamentally alter our understanding of ourselves and the universe. It sounds like pure fantasy, a familiar trope from Pulp Fiction. That was my first thought. But delve deeper, and unsettling questions arise. Why would a seemingly outlandish urban legend captivate Neil Armstrong, a man of science and unparalleled experience? Could it be, as some speculate, that his interest was sparked by something he witnessed on the moon? Narrator July 21, 1969. Over 500 million people worldwide watch as Armstrong descends the lunar module's ladder and utters those immortal words. That's one small step for a man, one giant leap for mankind. Even decades later, those words inspire. Yet moments after, something strange occurred. 2 minutes of eerie radio silence. The official explanation: Armstrong switched to a private medical channel to convey information not meant for public ears. The alleged message: they had spotted unidentified objects near a crater. Objects resembling spacecraft, their occupants seemingly observing the astronauts. Incredible if true. NASA vehemently denied it. But the rumor, ironically, is said to have originated from within NASA itself, mere hours after the landing. And another unsettling detail: upon their return to Earth, the Apollo 11 crew weren't jubilant. They appeared subdued, tense, almost melancholic. Was it post-mission fatigue, or had they truly encountered something extraordinary? Narrator: Armstrong himself never publicly discussed those missing 2 minutes. But his subsequent, uncharacteristic actions suggest something on the moon profoundly impacted his worldview. The Teos Caves expedition is a prime example. The legend of the Teos Caves metal library originated with social sciences professor Juan Morix, based on accounts from his associate, Janos Joamkarixis, often conflated with earlier explorer Crespi and others like Halamillo from your original. He claimed a connection with the local Shuar people, who, in gratitude for kindness, shared a map leading to a place where all secrets converge. In the late 1960s, adapting the timeline slightly for Morix's main expedition period. Morix claimed to have followed this map and discovered the library: thousands of metal books on shelves, each weighing around 20 kilograms, every page etched with unreadable texts, geometric patterns, and symbols. Again, an urban legend. Most would dismiss it, but not Armstrong. Decades after Morix's claimed discovery, Armstrong spearheaded the largest, most organized search for it yet. The Teos Caves were located, but reaching them was an ordeal, a multi-day trek through dense rainforest. Inside, Armstrong was reportedly stunned by rooms the size of cathedrals. Their precisely cut walls suggesting artificial construction, a view supported by accompanying geologists who noted clear man-made tool marks and weathering indicating thousands of years of age. Who would undertake such a colossal project deep in the rainforest millennia ago? And for what purpose? Further exploration revealed a seated skeleton, dated to around 1500 BC, positioned directly beneath an opening in the cave ceiling, through which light would precisely illuminate it. Its placement suggested cosmological significance. But as the expedition pressed on, the passages narrowed, and the legendary library remained elusive. After 3 weeks, the search was abandoned. Armstrong's palpable disappointment was noted by many. What was he so desperately seeking? He never explained his involvement in this seemingly bizarre quest, and grew increasingly reclusive. In 1985, another enigmatic endeavor, Armstrong assembled a team of elite explorers, including Sir Edmund Hillary, first to summit Everest, and Steve Fawcett, famed solo circumnavigator, for a secretive expedition to the North Pole. The mission's existence was only revealed upon their return. Armstrong stated he merely wanted to see the pole from ground level, having only viewed it from space. But rumors persisted he was searching for traces of extraterrestrial civilizations, possibly linked to theories of alien bases at the poles. These rumors gain a sliver of credibility when you consider if you knew aliens existed, perhaps from a lunar encounter. Would searching for their bases seem so far-fetched? If you'd seen a tiger fly, you'd look up when someone shouted. Armstrong wasn't the only astronaut whose life took an unusual turn post-moon mission. Edgar Mitchell, Apollo 14, sixth man on the moon, a decorated astronaut with a brilliant future. Yet, in 1972, he retired from NASA and the Navy to found the Institute of Noetic Sciences, dedicated to studying consciousness and psi phenomena, subjects many deem pseudoscience. Why would an IT-educated astronaut embrace such concepts? Mitchell claimed that during his return from the moon, he experienced a profound epiphany, a sense of interconnectedness, the onness of the individual soul and the universal spirit, and an awareness of a creator's will. This creator isn't necessarily a religious deity. Physicists like Yang Chen, Ning have spoken of a creator as the fundamental, elegant order of the universe, the underlying principles beyond human comprehension. Mitchell, not a devout Christian, likely meant something similar, or perhaps, as many suspect, something more alien. Post-return Mitchell, previously indifferent to UFOs, became an outspoken advocate for their reality, claiming governments were covering up alien contact, including the Roswell incident and recovered extraterrestrial bodies. His creator's will experience, viewed through this lens, might have been a profound extraterrestrial sighting that reshaped his reality. Then there's James Irwin, Apollo 15, eighth man on the moon, first to drive the lunar rover. Like Mitchell, he retired soon after his mission, founding a religious organization, High Flight Foundation, and dedicating years to searching for Noah's Ark on Mount Ararat in Turkey. Noah's Ark, a biblical story. An educated astronaut like Irwin would know its allegorical nature. Why the obsessive search, unless an experience led him to believe in its literal, or perhaps alternative, reality? One fringe theory posits Noah's Ark wasn't a wooden vessel, but an alien spacecraft, a DNA collection ship, preserving genetic material to repopulate Earth after a cataclysm. If Irwin had witnessed something that lent credence to such extraordinary ideas, his quest becomes more understandable. When asked why he founded High Flight, Irwin spoke of feeling the Creator's presence and warmth in space. If this Creator, as with Mitchell, was a euphemism for an advanced extraterrestrial intelligence, it paints a chilling picture. Are we being observed? Are we perhaps part of a grand cosmic experiment? Transition music visuals. This brings us to a fundamental question many have pondered. In 1960, astronomer Frank Drake initiated Project Ozma, using a radio telescope to listen for signals from nearby sun, like stars Tau Ceti and Epsilon Eridani, marking humanity's formal search for extraterrestrial intelligence a set I. Uncertain where to look, scientists adopted a two-pronged approach, broadcasting messages about humanity and Earth towards dense star regions, like the 1974 Arecibo message, and focusing on habitable exoplanets as potential cradles for life. What defines a habitable planet? Generally Earth-like conditions, similar gravity, located within its star's habitable zone, where liquid water can exist, and not overly geologically violent. Crucially, the presence of liquid water and an oxygen-rich atmosphere. For decades, atmospheric oxygen has been a key biosignature. Yet, this criterion faces criticism. Isn't it geocentric to assume alien life requires what we need? The universe is vast, life could be vastly different, perhaps breathing hydrogen and drinking liquid methane. So, is this focus on oxygen a failure of imagination by scientists? Let's explore this from oxygen's perspective. Oxygen is essential for us, leading many to assume it's a prerequisite for all life, or even for life's origin. This isn't quite right. Abundant free oxygen is in fact a miracle created by life. A lifeless rocky planet is unlikely to possess a significant oxygen atmosphere. Why? It's down to oxygen's chemical nature. Atoms strive for stability, typically by having a full outer electron shell. Oxygen has 6 electrons in its outer shell. It desperately wants 2 more to reach a stable 8. It's far easier to gain 2 than to lose 6. This makes oxygen highly reactive. Left to its own devices, it readily combines with other elements, rarely existing in its free O2 form. In our hydrogen-rich universe, oxygen easily forms water, H2O. On massive planets with strong gravity, hydrogen is abundant, so free oxygen is scarce. On smaller bodies, If hydrogen escapes, oxygen often escapes with it. Even on a perfectly sized rocky planet, elements like silicon, aluminum, and calcium in the rocks eagerly bond with oxygen. And then there's carbon. Oxygen's bond with carbon forming CO2 is incredibly stable. So, without life, a rocky planet's atmosphere is typically dominated by carbon dioxide and nitrogen, or methane and ammonia if hydrogen is more plentiful. Earth itself is the prime example of an exception driven by life. Early Earth's atmosphere was primarily CO2, nitrogen, and methane. Oxygen was locked in water. It was an anoxic world. How did it transform? Through the miracle of life. Around 3.5 billion years ago, cyanobacteria, simple single-celled organisms, evolved a revolutionary skill: photosynthesis. Using sunlight, water, and atmospheric CO2, they produced sugars for energy, their waste product, oxygen. For a billion years, these cyanobacteria proliferated. Initially, the released oxygen was absorbed by iron and other minerals in rocks and oceans. But eventually, these sinks became saturated, and oxygen began to accumulate in the atmosphere. This great oxidation event was catastrophic for most existing life, which was anaerobic. About 99.5% of life forms went extinct. It was Earth's first major mass extinction. Crucially, even after this event, atmospheric oxygen remained low, around 1% for over a billion years, only around 580 to 520 million years ago. During a second major oxidation event likely linked to massive mountain building, did oxygen levels rise significantly, reaching over 60% of modern levels. This triggered the Cambrian explosion, a rapid diversification of complex multicellular life. Essentially, life, particularly plant life performing photosynthesis, temporarily stripped carbon from the atmosphere, allowing free oxygen to become a major component. If all life on Earth vanished, our atmosphere would eventually revert to a CO2 and nitrogen mix. Thus, abundant free oxygen is a strong biosignature, a sign of life, and a prerequisite for complex ecosystems like ours. Evidence suggests Mars once had vast oceans and was habitable. Its dry riverbeds and scattered pebbles tell this story. Even Venus, now a hellscape, shows signs of ancient granite, which requires water to form, hinting at a past with oceans. So, all three rocky planets Earth, Mars, Venus, formed from the same nebular material in the Sun's habitable zone. Why did Mars lose its water and become barren? High-energy solar radiation split water into hydrogen and oxygen. Light hydrogen easily escaped into space. The remaining oxygen reacted with surface materials, creating iron oxides, hence Mars's red color. Earth's water also undergoes this process, but our vast oceans and active geological cycle, including oxygen production by life, allow hydrogen to be re-oxidized and returned as water before too much is lost. Abundant oxygen helps a planet retain its oceans. Furthermore, aerobic respiration using oxygen is vastly more efficient than anaerobic respiration, releasing about 40% of a substance's energy compared to just 10%. This energy surplus fuels more complex food chains, larger organisms, and greater biodiversity. Without the evolutionary path of aerobic respiration, Earth's biosphere would be far simpler, and intelligent life like humans might never have arisen. So, searching for oxygen isn't just about finding life as we know it. It's about finding conditions conducive to complex, detectable life. But could aliens breathe nitrogen? Of course. Scientists are not limited in imagination. Science fiction author and biochemist Isaac Asimov proposed 6 possible biochemistries. Only one, carbon-based life in water like is familiar. He ranked silicon-based life as a strong contender due to silicon's abundance, especially on rocky planets, where it outnumbers carbon 925 to 1, its ability to form stable, complex chains, and the possibility of liquid fluorosilicone compounds serving as a solvent, meaning silicon life wouldn't necessarily be slow, rock-like, or require extreme heat. Given silicon's apparent advantages, why did life on Earth choose carbon? That's a topic for another exploration die. The point is, while alien life might breathe nitrogen, drink sulfuric acid, or eat rocks, such speculative biochemistries offer few practical starting points for our search. We don't definitively know all the conditions necessary or unnecessary for life's genesis. We only know our earthly conditions demonstrably did produce life and complex intelligence. Imagine you're a solitary crab searching for others of your kind. Your best bet is to search environments you thrive in. Lakes, oceans, swamps, deserts, or mountaintops might harbor a uniquely adapted crab, But with limited resources, you search where success is most probable. Similarly, scientists search for Earth-like environments because they represent a known pathway to life. It's a pragmatic approach to an immense challenge. Perhaps one day, upon discovering truly alien life, we'll revise our search criteria. But until then, we look for mirrors of ourselves and the conditions that allowed us to look up at the stars and wonder.